This series of lectures is going to cover Chapter 5 in the Singer text, which is all about endocrinology. And just to give you fair warning, this is a really in-depth part of the reproductive physiology discipline, and so we're gonna work through this lecture over a couple of weeks. And so endocrinology is the study of hormones. And hormones are an essential part of the reproductive physiology process. And more specifically, the hormones are going to be not only secreted in response to some sort of activation, but they are going to be received by a target tissue to set off a whole nother effect. And so the reproductive cyclicity cycle, regardless of species, is really essential and dependent on hormones. So this is the last table in Chapter 5 of the Singer book, and this is a really essential table. I encourage you to study it, build some flashcards off of it, because you guys are going to need to know the names of the hormones, how they're classified from a biochemical standpoint, the tissue that they're secreted from, and then their target tissues, both in the male and the female, as well as their primary actions. And so this is a great place to just get all of this information in one area. So with with reproduction, it is going to be regulated by two different systems. And as my mentor in graduate school at New Mexico State, Dr. Halford, used to say, it's all about nerves and hormones, y'all. And that's exactly what reproduction is about. And so the nervous system and the endocrine system work together in a really intricate relationship to carry out reproductive function. And so as we start looking at reproductive function, we have to start with the discipline or the area of neural control. And so neural, just keep in mind, refers to nerves and specifically neurons. And so those nerves and neurons can actually be controlled through two major types of reflexes, which is a simple neuroreflex where just the neurons do the work. There's no hormones involved. And then a neuroendocrine reflex, which is the neurons plus the hormones, or the neural hormones actually more specifically do the work. And so with neural control, the system actually requires a lot of different components to carry this process out. So it requires sensory neurons, the spinal cord, efferent neurons that are nerves that leave the spinal cord and travel to a target tissue, and then the target tissues. And target tissues, again, is exactly what it said. It is the tissue that is targeted by a hormone. So let's first look at a simple neural reflex. And so we have, with this type of system, we've got some sort of stimulus here. And so the easiest one to kind of relate to is when you were a kid or maybe an adult, not judging, and you went to the doctor's office and you sat on, the bench in the exam room, and he would pull out the fancy knee hammer and he would hit just below your kneecap, and your leg would, or the lower part of your leg would automatically do a reflex. And so that is a simple neural reflex. And so the doctor was checking your reflexes to make sure everything was okay. And so this is the type of reflex that we can, or one type of reflex that we can see, to where there is a stimulus or some sort of tactical stimulation. It could even be temperature related or thermal, or it could be visual. And so that stimulus is going to send a message to a sensory nerve ending. So this could be in skin, it could be in the retina, it could be have to do with a lot of other different types of nerve endings and other tissues. And that sensory nerve ending is going to recognize that stimulus and is going to send a message through the afferent neurons that are hooked into the spinal cord. We're going to get an exchange of information here in the spinal cord, and then the message is going to travel back out through the efferent neurons, so the neurons that go from the spinal cord to the target tissue. And it's going to elicit some sort of response in the target tissue. Specifically, it's actually going to secrete neurotransmitters at that tissue. And so these types of reflexes that we see in reproduction are like muscle stimulation for sexual behavior and ejaculation in the male. We also see the muscles that are associated with the scrotal tone, like we talked about in chapter 3, respond in this type of reflex, as well as the scrotal sweat glands. The second type of neuroendocrine reflex, or the second type of system, is the neuroendocrine reflex. So again, this is an intricate relationship between not only nerves, but hormones that are going to be synthesized. And so these neuroendocrine cells are located in the brain tissue. And so an example of this would include part of the transportation system that we see in the simple neural reflex. So we get some sort of stimulus, it's captured by the sensory nerve ending, it sends that message via the afferent neurons to the spinal cord, and then instead of being redirected back out to the efferent neurons specifically, the message actually will travel from the spinal cord to the brain tissue, and specifically here the hypothalamus, which is this top portion shown in this figure here. And so in the hypothalamus, these nerves are going to be connected to neurons in the hypothalamus. And in this case, and in a lot of the cases that has to do with reproduction, that neuron is a gonadotropin releasing hormone neuron, or a GnRH neuron. And so these neurons are located in the hypothalamus. They have really long axons and bodies, and they actually will elicit some sort of response to the pituitary gland, and we'll get into that, what that is more specifically. And so some of the responses can result in like FSH being produced, LH being produced if it's coming from the anterior pituitary, or if it's a message that is going from the hypothalamus through to the posterior pituitary, then we could have something like oxytocin being released. And so this is a common reflex that we see in reproduction all the time. So if you envision back over here with the stimulus, a calf or a lamb actually really hungry and trying to find mom, and they're bawling, and once they find mom, they go right to the udder and they start hitting their head against the udder, and that stimulates milk release. And so that tactile stimulation is sending the message through those neurons through to the spinal cord, and then from the spinal cord up to the hypothalamus, and then the hypothalamus is going to connect to the oxytocin neurons that are housed partially in the hypothalamus, and then the tail or the dendrites are going to be housed in the pituitary gland. And so here oxytocin would be released. Oxytocin would then go into the blood system and travel to the mammary gland tissue, and milk would be released. And so it takes a little bit of time, but in all reality, it's actually fairly quick. And so we see this on the male side too, with sperm actually being moved from the tail of the epididymis into the ductus deferens when a male is getting ready to mount or go through the copulation process with a female. And so these are just a visual of the two reflexes that we see that are really essential in reproduction. So again, simple neural reflex and neuroendocrine. So if we look at this on a step-by-step basis, the stimulus is going to cause the sensory neurons to recognize the stimulus. That message is going to be transmitted to the spinal cord and the interneurons. And then we have, in the case of a simple neural reflex, like your leg moving when the doctor hits just below your knee, the message is then going to be rerouted through the efferent neurons, head to the neurotransmitter, then the target tissue, then the response by the target, or then we see some sort of response at the target tissue. On the neuroendocrine response, that message coming into the efferent neurons in the spinal cord is then rerouted to the hypothalamus. We get some sort of stimulation of the neurohormone. That neurohormone is then secreted into the bloodstream, which travels to a target tissue, and we get some sort of response by the target tissue. So you can tell just in the length of these pathways that one is really short and happens really quickly, and that's the simple neural one. And one takes a little bit more time, and that's the neuroendocrine one.